Good afternoon. My name is Mike Cagney, and in this short video, I would like to show how you can set up a particular orbit model and use the advanced channel emulator. So in this demo, I'm going to use the SATGEN real-time emulation software package that we manufacture. Let's say I want to add a satellite, and the satellite is not in our database. I can use a two-line element data set to import it. This is the specifications for the two-line element data set. So I'm going to go to a NORAD internet package, and I'm going to select a particular satellite. So let's take the Galaxy 28 satellite, and I'm going to paste that into SATGEN and import it and save to the database. So here's the satellite that we just entered. It's described by these orbital parameters. Let's say also for this model, I'm going to enter different Earth stations. So let's say I'm going to import from our database. We can also enter it by specifying things like latitude and longitude. So let's say I'm going to import New York, save to the database. I'm also going to import, let's say, Los Angeles. To make this demo a little bit more complex, let's also assume I have an aircraft in the mix. So I'm going to come along and specify an aircraft, and I'm just going to locate the aircraft on the map. I'll accept that, call it aircraft 1, and save it to the database. So now I've set all that up. So I have my satellite described here, I have my ground stations, and I have my aircraft. The next thing I need to do is specify the uplink and downlink frequencies for this. So let's go to the link configuration, and let's assume I'm going to go from New York up to the Galaxy 28, let's say down to Los Angeles. I'm going to have an uplink frequency of, let's say, 10 gigahertz, downlink frequency of 14 gigahertz. And on the other channel, I'm going to go from, let's say, the aircraft up to Galaxy 28 and also to Los Angeles. And let's specify different link frequencies for those. Now I also have to specify the names of the files that I'm going to generate. I'll just use the default names that are shown here as opposed to typing in new names. So I'm going to run an emulation for 1 hour with a 100 picosecond resolution. I'm going to save those settings. Now we have two modes in which we can run this emulation. I can run what we call data pump or real-time emulation mode. So I have now connected with the instrument, and let's bring up a camera view of the front panel of the ACE. So right now this shows that the ACE is in static mode. Nothing is changing in real time. If I want to run, I just hit start, and now we see everything has changed in reverse video. So what we are now doing is emulating, changing delays and changing Dopplers and signal attenuation and so on. Let me stop that emulation, and let's say I do not want to run in data pump mode. I want to run in, I want to pre-calculate all the data. So I can connect with the instrument again. And what I'm going to do is mathematically generate all these files. And now I'm uploading those files to the instrument. They are now there. So I can now run in the same mode as I was showing before. Let's stop this. So I'm going to exit real-time emulation mode. I'll terminate this program. Not going to bother saving the changes. And let's bring up the GUI for the instrument. I'll connect to the instrument. And if I want to, I'm uploading all the files from the instrument. And so these will be things like changing frequencies and changing Dopplers and so on. And now I can run the same simulation again. So here I'm running the files that are resident in the advanced channel emulator from that model that we just created. So that's all that's involved in creating orbit models and uploading the dynamic data files to the advanced channel emulator so we can run sophisticated handoffs between satellites and so on. So thank you very much for watching this video.